from MRG Laboratories, Matt Spurlock from Delta P Reliability Services, and Mike Johnson from Amory Lubrication Reliability Services. Anyway, thank you very much. We'll start out with each one will talk for about approximately 10, 15 minutes, whatever. Do a recap of what was discussed earlier, answer some questions that were asked of us earlier on and also offline, and then we'll finish out towards the beginning of the next hour. Thank you very much. First person up would be Rich Warsbach. Okay. While Rich is trying to get online, we'll hear from Matt Spurlock. How about it, Matt?
Okay, great. Thanks, Michael. The presentation that I was part of was around setting alarm limits for oil analysis and how those correlate with identifying issues with COVID. Michael Holloway was kind enough to actually do the presentation. I was not feeling quite myself that particular day, so he did a lot of legwork. So I certainly appreciate that. So the gist of that presentation was really around what we do with respect to alarm limits. We discussed doing statistical analysis for wear debris. We discussed setting target alarms for things like cleanliness and moisture. And we also talked about using what we call aging limits for fluid health properties, such as viscosity and oxidation and things of that nature. Now, viscosity is a little bit goofy because when we set those alarms for viscosity, while we may call that an aging limit, it's really not. It's an allowable parameter limit more so than anything else, because so many things can influence viscosity change beyond just age. But what I really want to dig a little bit into a little bit of depth on is the wear debris alarms, is using that statistical analysis, because as Mr. Holloway mentioned, ideally we want to have 10 or more samples from the same piece of equipment before we can do appropriate statistical alarms on that specific component. But what I want to take away, or what I want you to take away from here is that obviously the more data sets you have to feed into that statistical analysis, the better. Having said that, we don't need to wait until we have 10 or 20 or 30 samples. Some people out there say that we need to have 300 samples, and that's just not the case. Okay, we can actually identify what we would call a normal trend just after 3 samples. Okay, we can identify if something's running relatively normal or if it's not normal. Now, if we have a first-time sample on a given piece of equipment, then we can still establish alarms. We're just not going to be able to establish component-specific alarms. What we'll do then is look at the type of component it is, try to narrow it down to the make and manufacturer, and then use statistics based around that component, that make, that model of component, and even go so far as saying this make and model component working in this application should have alarms such as this. Okay, and what we learned from Mr. Holloway is that there's an actual ASTM standard around setting alarms, that we calculate the mean and the standard deviations, and that we will set what ASTM calls a white alarm at the mean plus 1 standard deviation. We'll set what we would call a cautionary type alarm at the mean plus 2 standard deviations, and then a critical alarm with the mean at the mean plus 3 standard deviations. Now, that's what we're technically supposed to do with wear debris alarms. The thing that you've got to be careful with are those metallic or those metals that are part of an alloy that don't necessarily show up a lot, because now your mean plus a standard deviation or 2 or 3 could be simply an increase by 3 ppm or a doubling. It depends on what your historical trend is. All right, so even following this statistical guideline, you're still going to end up with nuisance alarms. All right, we get it. Part of evaluating that data is not just saying, well, it hasn't reached an alarm point, so it must still be okay. You've got to look back and understand what the trend of that has been. If you're looking at an alloy or a minor metal that's part of an alloy, you need to make sure if that does increase, if it's been trending at 0 ppm and it jumps up to 3, that may or may not be indicative of a problem. You've got to go back and look at if there's any corroborating evidence or supporting data from any of the other primary or even secondary metals in that particular alloy. So that's really the gist of setting alarms, and we can go into a lot more depth around regression analysis, but then that's going to take us into yet an entire another hour. Or if you want to listen to Michael Holloway and I discuss it back and forth, we could have an 8-hour webinar doing that, I'm sure. So I guess right now what I would like to do is kind of open it up. If anybody has any questions that you would like to ask me around setting alarms for oil analysis, in your bar to the left, you'll see a little conversations box. Feel free to click on that conversation box and a questions and answers box. Click on that Q&A box and pose any questions that you may have, and I'm happy to address them over the next 10 or 15 minutes.
Matt, one of the things that someone had asked me offline was, what are use the term plug and chug. What would be the plug and chug method to just start out? If someone had maybe 10 assets and they had never done any oil analysis, like step 1, step 2, step 3, and on about a 50,000 foot level, I had just made the recommendation. Please chirp in if you want. About first of all, you gotta establish your testing. You gotta obviously make sure that you know what you're looking for in your test slate, not just sending in an oil analysis sample and getting back viscosity, metals, and water. But maybe there's some other things we want to look at. But really to reinforce that with, if we are looking at the characteristics of our assets in terms of its lubrication reliability, what kind of test methods would actually speak to that? And that's really where an oil analysis lab or someone like you or I or others can actually help point in that direction. But as soon as we start doing on that, then we take the data and we can actually throw it in a spreadsheet, plot out, and then, like I said, we could hand do the regressions, but now actually we could actually start plotting out to see where the lines are going. And that's kind of like the beginnings of the plug and chug, if you will. What do you think?
Yeah, those are all good points. Now, when I'm talking about setting up an oil analysis program for someone new, the very first thing, the very first discussion point that I have is machine selection. Do we have the right machine selected to ensure that we're getting value out of the program? And we can either do that by criticality. We can consider bad actors first. Several different ways that we can ensure that we've got the right machine selection. Once we have the right machine selected to ensure that we're getting value out of the program, then we need to define what our reliability objectives are on those machines. Are they such that we might warrant a combination of inline real-time condition monitoring supported by a periodic lab sample, commercial lab analysis? Is it a situation where no, we're fine with lab analysis? We don't want to do that inline monitoring yet. So once we define the reliability objectives, then we can define what the actual sampling strategy is. Once you define your sampling strategy, then you need to define your frequency, and you need to maintain that frequency. One of the worst things that can happen is you not having a consistent frequency on your oil sample collection and testing. It will skew the results. It will throw things off significantly, okay? Because there are two things that we want to avoid with oil condition monitoring. And the first one is a missed failure, okay? If a piece of equipment fails and oil analysis did not identify that potential failure, then it takes the credibility and throws it right in the trash can. The second thing we want to avoid doing is having customers, telling customers that they need to do some type of maintenance action when in fact they really don't. So both of those will mess with the credibility of the technology. And the third step in setting up the program is data integrity. The laboratory needs to have a minimum amount of information about that piece of equipment before we can do any type of relevant analysis. We can give you data all day long. Any lab out there can give you data. But the key behind oil analysis is getting relevant diagnostics and prognostics. What's wrong with the equipment, or what is the status of the equipment? If there's anything wrong with it, what do I need to do to fix it? And here's where a lot of facilities fail. Not only do we need to know what should we do in order to fix the problem, but what's going to happen if we don't fix the problem. And it's easy to say, well, the thing's going to catastrophically wreck. Well, no, prognostics isn't about saying it's going to catastrophically wreck, because we already know that if we just leave machines to run to failure, they're going to fail. Okay. The idea is trying to come up with some type of path for improvement, because if we don't improve this, then we're going to see this, then we're going to see that, and then this is going to happen. And ideally, we want some type of confidence probability in there as well. So the top three things is making sure you've got the right machine selected, you've got your test slate and your frequencies such that it meets your reliability objectives for each piece of equipment that you've accurately selected, and then ensuring the laboratory has the data, the accurate data that they need to be able to do their job. Now, if we talk about test slates specifically, a lot of laboratories have several different grades of testing. They have what they call the basic testing and then advanced testing. My professional opinion is that if your equipment is critical enough to be on an oil analysis condition monitoring program, then it's critical enough to have comprehensive testing. If you don't have comprehensive testing, then you will have missed opportunities. The days of the basic test slate have to be over if you want a true relevant oil condition monitoring program. So kind of a long-winded way to answer your question, or that question, Mike, but hopefully that answers it.
And I had another question had come into me was, hey, if we take a look at the regular basic tests that are typically run, what kind of tests are out there that a lot of us don't that the end users maybe not realize would be really valuable, that aren't necessarily either being marketed or used yet, but are on the horizon to becoming really valuable? My 2 cents, and I'll throw it over to you for another quarter and a half, is I always like not only the RPVOT but the ruler test, because I really do believe that those two tests give a really nice indication as far as the lubricant life in terms of oxidation stability. The ruler obviously being something that keeps a good eye on the phenols and the active amines, but also the ruler can be used, which a lot of folks don't realize, to understand the functionality of your anti-wear agent if it's zinc dithiophosphate. And you can actually even use the ruler to understand if you're getting an acid buildup, and you could actually establish a TAN or an acid number from it. And it's one of those tests that I don't know if a lot of folks really consider to be valuable going forward with understanding oil analysis and setting alarm limits. But I think there might be something out there that is starting to emerge and starting to become a lot more popular. I don't know if you could think about any other test or comment on that.
Well, you bring up two very good tests, Michael, but the base of the question was, as I understand it, is in addition to the basic test slate that people are getting today. In my opinion, the right way to address that is on a component specific basis, because your basic test slate in a lot of our large laboratories, your basic test slate consists of ICP, which is your elemental analysis, water by crackle, which is educated guess. Basically, it's a go, no-go test. Viscosity, and maybe FTIR. Now even FTIR, there are methods with FTIR where you can estimate acid number and base number, and some of these methods can be pretty accurate, but doing that as part of a basic test slate is not generally part of that testing. So, and that basic test slate is really what's kind of offered across the board, no matter what component type we're talking about. Now, with respect to RPVOT, we're going to use that on those systems where we expect a lot of years, a lot of time out of that fluid. So turbines are great examples of this. We may have a turbine or a turbine, however you want to pronounce that, oil in a system for 30 years. Okay, certainly 5 years, but as much as 30 years or even more. So a RPVOT and even a ruler should be part of the natural test slate, not necessarily on every sample that comes into the lab basis, but there will be a frequency. Now the ruler can be, but the RPVOT is likely going to be either a 3, 6, or 12-month type of interval, simply because of the time and resources it takes to do that particular test. What we're not necessarily going to do, though, is an RPVOT on a hydraulic system. It would be great if we could. I mean, we can, but the problem with industrial hydraulics and even mobile equipment hydraulics is the old adage, like we learned in the military: if you're flying on a helo and you don't see hydraulic fluid leaking out of the top, then that means it's out of fluid. Well, the same thing holds true in a lot of our hydraulic systems in mobile applications and even industrial applications. There's no need really to monitor the remaining useful life of that hydraulic system, because the top up rate is so high. You're constantly adding new fluid to it anyway. If we could get into those facilities and control those leaks, then yes, RPVOT would be very good, as would the ruler test. I don't have a ruler test in a ruler instrument in my R&D facility right now, but I know that Rich Wurzbach has one. So when he jumps back in, he may be able to give you a little bit more details around how he may use his particular ruler to help support some of the more in-depth type testing. But what I think we really want to do from a routine analysis standpoint is move up from our basic, what I would call doing oil analysis just because we were told to type of test slate, up to a more comprehensive test slate that is cost effective to do on that routine basis. And in my professional opinion, that routine basis needs to be more frequently than every 90 days, which is arguably the most common sampling interval for industrial equipment. You got to remember that when you pull that sample, you're only testing what the condition of that machine and that oil was at that particular point in time that you pulled the sample. Okay, a lot can happen in a 90-day timeline. Rich, I saw you log in real quick. Did you want to get kind of help out with Holloway's question that somebody asked him around using a ruler on a more routine basis? I believe you've got one in your facility. How do you guys implement that to support your customers?
Yeah, thanks, Matt. Yeah, it really does circle back to what you said, Matt, which is that the test slate really needs to be developed around the specific components and what the customer is trying to do with the data. If you're in an environment where folks have not moved away at all from a time-based oil change kind of approach, the ruler's not going to add a whole lot. On the other hand, if you're talking about larger reservoirs where we're trying to extend the life out, and I think where it really comes into play is those environments where either there's been a history of oils degrading to a point where there's significant secondary work that's necessary to recover from that. And I'm talking about varnish and deposits and things like that that occur when your oil really is allowed to degrade. The nice thing about the ruler technology, the linear sweep voltammetry, is that we get to monitor the health of the oil or the grease in a proactive way. And I think that just needs to be in alignment with the organization's actions and goals around the assets that you would apply this to. But I think anytime you have a really large reservoir where a change out would be very costly and time consuming, it's certainly a tool to kind of pull into the routine testing. It's not thought of as much for greases, but we've had some really good luck using ruler for greases, especially in those environments where the grease tends to get, kind of more thoroughly mixed and so forth, and you don't get these little pockets of new grease and old grease and whatnot. But Mike Johnson and I just finished a project, an aerospace project, where the ruler played a very strong role in determining what the optimal grease replenishment frequency should be. And that was accomplished by looking at a large number of assets, aerospace assets, and looking at the ruler levels over different operating hour periods to determine how quickly is that grease actually degrading to optimize its use. Now, I know, Mike, you're on there. Did you want to add something?
Yeah, a question for both you guys, particularly for large circulating and or hydraulic systems. Where do you see the value of micropatch calorimetry to measure varnish potential? How often should that be done? Is that part of the default test slate, or would that be considered a secondary test? And what kind of long-term management potential do you think micropatch calorimetry or varnish potential testing gives to the machine owner?
Yeah, so I'll tell you how we use it, and it generally it again depends on the application and really the maintenance strategies employed by the customer that owns that asset. Again, if an organization is very much on top of the health of their lubricants, they're looking at the ruler results, they are either doing bleed and feed or wholesale change out, or maybe readditization, perhaps in a very large reservoir where that makes sense and that can be determined properly, then you maintain a very healthy oil. And it may only be that you trigger on MPC when, by circumstances, the oil gets into a very low protection environment as far as the additives go and is at risk for developing that varnish. In other situations, it could be assets that periodically experience high oxidation stress conditions, and you want to see what the cumulative effect of that is. That's where MPC comes into play. It goes to criticality, which Matt was mentioning as well. So I think it's a combination of the criticality of the component, the impact that varnish would have on that particular component, and then what the maintenance goals for the asset are for that particular customer. In some cases, it's a periodic or on condition test. In other cases, that's something that folks monitor each time they take a sample. Matt, did you have something to add?
No, Rich, but Jorge did add a question that I will ask you. I will let you answer, and then we'll go ahead and transition, since you're live on the mic, go ahead and transition into your review on your presentation, and then deal with some questions specific to that. But Jorge asks, is there any relation between ruler and organic additives concentration? So again, once you answer that, I'll let you just segue right into your review.
Okay, so the question was ruler and organic additives. Well, I think one is a more broad term, and that is organic additives. There's a number of different compounds, if you will, that could be used as additives that are organic in nature. And some of them are the antioxidant additives like the phenols, the hindered phenols, and the aromatic amines. But there's other organic additives that are used as well. Tricresyl phosphate, which is a non-zinc anti-wear, is an organic additive. We can think of certain anti-foaming additives as organic additives. So the ruler is very specific in what it targets. It's looking at the phenols and the amines, and does have the ability to pick up sometimes the ZDDP peaks. There's different types of phenols and amines, and it can be fairly effective at picking them up. Organic additives is a much broader classification of additives, and I think we need to set our expectations for ruler just onto those antioxidant organic additives.
Let me chirp in there real quick, Rich. That was excellent answer. One of the things about the rule, like you mentioned before, it's sweet volumetry, and really when you're taking a look at the phenolic concentration and the amine concentrations, and you're using, obviously, with the ruler, if for those of you who don't know, with a ruler test, you got to use a reference and then compare against the test sample, correct? But now it's really what you're looking at is the electrochemical potential of the reactions that can occur. And really, you're looking at some active groups that are on this additive, and it's an examination of electrochemistry of it all. Now that is translatable to certain additives. Now, not all of them, because there's different types of additives that have different types of electrochemical responses. It just so happens the phenolics and the amines and the phosphates definitely have that kind of way in which we can look at the sweet volumetry, which is essentially the potential that's going on the molecular level. So that lends itself quite nicely. Now the other thing too is that if you really want to get technical, it really gets into what's called proton doning and so forth, which we don't have to go there. But I don't know if enough research has actually been done to really explore totally what sweet volumetry has to offer in terms of other types of examinations with other additives. And I have a feeling that there's a lot more that can be occurring down the line with this. Really, it's an old technology. It's been around for a number of years, but I don't know if it's been completely explored to the point where we could really take full advantage of it. And, to Matt's point earlier, because I know he's got a true love for inline oil analysis and so forth, that's one particular type of technology that I think might be a way to lend itself to that kind of application as well down the line.
Yeah, Mike, great points. One rather interesting application for ruler, and it's not often thought of as having value here, is in the monitoring of phosphate esters. And a typical phosphate ester as a fire-resistant hydraulic fluid has little to no additives. It's just the phosphate ester functionality itself that provides anti-wear capabilities and its function as a hydraulic fluid. But when it degrades, which is primarily a hydrolysis reaction, the hydrolysis of that phosphate ester produces a byproduct which is measured by the ruler. So it becomes a tool that we can add to our phosphate ester monitoring test slate, so that we can look very closely. And this goes to what you just said, which is, cyclic voltammetry itself is, rather an old technique. And really, you're right. It's just looking at that electrochemical potential. And that's just one area that it's been applied to an oil that doesn't even really start with an additive. Yeah,
and we all always realize that it's all about oxidation. And when the molecule goes through the oxidation and reduction process, the potential changes with that. And on the surface, you could say, well, is conductivity changing? But it's a lot more than that. There's really, really subtle nuances occurring. And when that reaction does occur, so you can take a look at what's actually happening. And I think, like you said, it's emerging technology that is barely being scratched on the surface. Anyway, we're busting into the 10 to the half past hour right now, and I think, Rich, probably we got a couple more things to say about the stuff you had explored, and then we'll probably turn it over to Mike, and then I'll round it out. Or if we swap the other way, it doesn't matter to me.
No, that sounds good to me. I just had a couple points I wanted to make in addition to kind of what I presented earlier this week on Wednesday about the impact of COVID-19 on this model of the central labs, or the sampling and sending it to these central labs. And I talked about how the stay-at-home orders are impacting things. For the labs themselves, it's impacting personnel availability to take samples in the field, and it's been a drain on, or a drawdown, if you will, on the number of samples that are being taken and sent out. And then we talked about some things that happen when you have equipment that is kind of on standby, or maybe even being mothballed for an extended period. So what I did is I took this kind of principle, and I went into the website for ICML. And Paul Hiller from ICML posted something in LinkedIn last week. And in that, Paul was talking about, or just asking really to a number of ICML certified individuals, how is this impacting your business or your businesses? And here's one of the responses that Paul got from an ICML certified individual, Marcelo Robert, and he's working in the Chilean mining industry. He talked about the contraction of the available people to do the jobs, the restriction of movement here with COVID, and kind of preventing contact between people, and that's been an impact on human resources. What he is saying is the condition monitoring has been very important in the past to prevent failures, and it could be a big problem in this current situation where we just don't have the number of people in the spaces that we typically would that could gather these samples and send them off. So that's going to be an area of concern. In addition to the mining industry there in Chile, Zach Shively from Greenpoint Metals here in the States, his comment were, these circumstances make it really difficult even to get the lubricants they need. So it's a supply chain disruption, and that set them back in their PDM, their lubrication program that he's developing. It's a budgeting issue, right? The budgets are in many cases being scaled back, and so it's we're looking at what is the absolute minimum critical that we need to be doing right now, and many times taking oil samples and sending them to labs is not cutting that criteria and making it to allow people to take those samples. And there were a couple of comments from some laboratories in there as well. There was an overseas laboratory that was talking about their experience in the Middle East, and said that their sample flow had been cut already to 30% of what it typically is. And you can imagine what kind of impact that has. So the issues here are on the sample collection side, as well as the ability of the laboratories to execute once the samples come in. And I think that these points were well made by the folks in ICML that were interviewed by Paul for this article. And I think it just reinforces some of the things I talked about, which is, for those of us who are not the handful that are still going on site, putting on our PPE and doing the minimum to keep the plants running that are critical, the rest of us need to take this time that we have to think about how is it going to be different going forward. And I mentioned a couple of pressures that I think were always there and might even become more dramatic as we go on, and that's in the area of sensors, the adoption of sensors, which in some cases minimize or even eliminate the need to take samples, but at a very minimum, minimize the sampling activities, because we can wait until we see a sensor change to prompt that sampling activity. Ultimately, downstream, that means the labs are going to have to look at things differently. They just can't rely on the flow of samples that they have in the past. It's, I believe, going to lead to some diversification. Laboratories offering other kinds of fluids analysis, maybe grease analysis, where there aren't really sensor options there to kind of take that place, and we still have some critical components that we need to understand their lubricant function and what the condition is and so forth through grease sampling and analysis. And I think just embracing this kind of new normal of there's fewer people out there just to just to send a constant steady flow of samples out. So how does the expertise that has been built up, and there's some really great expertise out there for these laboratories, how do we get that applied to this new stream of data that's going to be coming from these sensors? A lot of the sensor companies are really good at building sensors that can take the measurements and get that data where it needs to go. Some don't have a very strong component that understands how you then take data and apply it to lubricant optimization. And so there's an opportunity here as time goes on. So I just wanted to kind of re-emphasize my point from my presentation on Wednesday and use some of the, these articles that were put together by ICML to kind of, reinforce that we're rolling into a very different kind of working environment. And I'll see if anybody has any other comments or questions on that.
Rich, question for you. We talked a little bit about differences in lubricant performance attributes and the prospect that it's possible to step into a higher grade lubricant as a means for extending normal replenishment intervals required from our day in, day out work activities. Which attribute would you encourage the audience to focus on from the conventional grease test data represented in the product data sheet? Which attribute would you suggest they look at that gives the best sense of the potential to extend lubricant grease replenishment intervals based upon all the testing that you've done over the years?
Boy, Mike, it's a good question. It's probably the first place people go to look when they're comparing products that they're using now and products that they might be considering for use. I don't know that the information you need to make that assessment is typically found in the product data sheets for greases. And I say that because the performance that we're talking about here, there's usually information about ball wear and the anti-wear capabilities and certainly the base oil viscosity and things like that. And I think for the most part, they're meant to make sure that the product chosen has the minimum capabilities for the application at hand. But when we think about superior products that might reduce the manpower requirement for optimal lubrication by extending the intervals, I think what we're talking about there is resistance to oxidation and mechanical stressors. And with that's going to lead us into looking for products that are matched up to the application and are going to have those properties persisting months and maybe even years into the future. And I don't know that most product data sheets have the kind of data that helps you assess that. I'll give an example. I might have mentioned this in one of my presentations earlier that the nuclear power industry has had an initiative for some time now called the Nuclear Promise, where they're looking to reduce manpower requirements to be more competitive, because it's understood that a huge component of the cost of generating nuclear power is really the labor component that's there in engineering and safety precautions and the number of people that walk through a plant and need to maintain it. So they're looking for this reduction in labor requirement, and it's a timely thing now because it's not just the nuclear power industry that needs to be thinking about that. It's really all of us that's going to have this labor constraint. And some of the initiatives that they have pursued are very specific to the nuclear industry, but one that I got involved with was creating a test stand to evaluate different bearing technologies as well as different grease technologies to see how they would hold up in a simulated long-term operating cycle without intervention, meaning that how long could we go? And the target in the nuclear power industry is about 2 years. About every 2 years, the plant is shut down for refueling. And if you can go that long without a certain maintenance task, you can bring in the people during the outage to do it, and not have to have a higher staff level throughout the year. And in that case, what we were able to find was a combination of a kind of an advanced non-contact seal on the bearing, along with a synthetic base oil and synthetic grease thickener, got us to that simulated 2-year interval for the bearings that we tested, whereas the others we saw grease degradation in a several month period. So if you can take and reduce by a factor of 4 the labor required for re-greasing, it can be very much worth the investment of a higher price point grease. Did that help, Mike?
Thanks, Rich. I appreciate it.
No, it's a good answer. One thing, if I could just jump on top of that and move on, is a lot of times folks will take a look at a product data sheet from a lubricant manufacturer, and it'll have some of the regular test data on there, and some of it makes sense, and some of it it's probably not even useful at all. But when one goes through the act of a failure mode and effect analysis, they can start doing those bearing autopsies and really identify exactly why these bearings are failing, and really get a grasp of the failure mode. Now, let's say you're in an environment where it's relatively dry, so water washout and water spray off and those kind of things aren't that big a factor in your grease selection, but perhaps it's a very high heat environment or a high stress load, very high load environment. Well, in that case, obviously there's, the dropping point might be some consideration. Maybe you want to have a synthetic base oil in your grease, but also looking at the 4-ball weld and wear might be a consideration. But if you take the time to consider that the failure mode and how that ASTM test speaks to the very performance to offset that failure mode, that begins the process of determining which properties of a grease or an oil would actually look to address the failure mode with that. And then you could actually just table it up and say, okay, I'm going to try this particular grease in this environment for several of my bearings, put it through the paces and compare what I'm using now and see if these test parameters do actually address this. And if I'm going with a grease that's got a higher performance value for these properties, perhaps this points me in the direction that I should be going to there to begin with. So, and sometimes we're going to notice, and you guys have probably seen this on these technical data sheets, they don't have all the properties that are really going to be addressing these failure modes that I'm so interested in. So that's when like a lab like yours, Rich, comes into play, where you do look into things much deeper than, say, a lubricant manufacturer may put on their technical data sheet. And that would actually help the end user really determine where to go with their selection process.
Yeah, Mike, it's a good point. And we, for some time, have been helping folks with root cause failure analysis. And, sometimes that's just thought of as a metallurgical exercise where, someone's cutting things open and magnifying them and Sharpie, hardness testing and things like that. But we really bring the lubricant analysis into that process, because so much of the information about what led to a failure can be found in the lubricant and then be coupled with the findings of wear patterns and things like that. But I also want to point out one important consideration when folks are trying to look for ways to extend lubricant intervals and the effectiveness of their oils or greases, especially over those intervals. And that goes to contamination. One of the strategies for greasing is you grease to purge contaminants. And, I just see too many folks that say, well, we're in a very dirty environment and we're just going to have to put a lot of grease in there. And I think there needs to be a mindset of how can we better shield the equipment? How can we keep the contaminants away? How can we minimize that contaminant ingression? Because even a high dollar grease is going to have to be flushed away if too much dirt, too much moisture, processed materials get into that grease and render it unsuitable for continued use. So really keeping out, controlling the contaminants is a whole nother process in addition to, thinking about investing in the higher cost and perhaps longer lived greases.
Excellent point. Really good point. All the more reason to go out and get your certifications. I think you develop a whole new love of the foundation of the knowledge, and you can start applying it out in the field. I won't talk too much about that, but I do want to get over to Mike Johnson, because I know he's been chomping at the bit to say his piece for the next several minutes and so forth. So, Mike, why don't you recap what we talked about and your discussion yesterday, and take it one step further.
Thanks, Mike. I appreciate that. In my presentation yesterday, talked about quantifying the actual labor requirements for the lubrication program, as Rich has pretty clearly laid out, and commentary coming back from various quarters. We are all getting stressed substantially for available labor. We are chopped up into smaller teams. We have fewer people operating in the plant environment at a given point in time, and there's no time like now to simply skip doing the machine lubrication tasks. But I would like to take a 30,000-foot view and strongly encourage listeners to resist the urge for short-circuiting the day-in, day-out routine care and feeding of machines. I've stated previously that this thing that we do on a day-in, day-out basis is the single most important opportunity we have for the technician on a daily basis to protect machine rotating equipment reliability. It is, of all the many things that we have available for us to do, it's a truly proactive, life cycle extending opportunity that exists in our hands in the form of a grease gun and an oil pail. And to that end, it's one of the few pathways we had to support long-term health of the machines, and then as a consequence of that, long-term health of the enterprise. Machine lubrication has been characterized as part art and part science. And in my presentation yesterday, I kind of resisted the whole notion of its artwork. And constructing lubricants is a bit of artwork, and there's a lot of creativity involved in formulating new recipes. But for our part, once we get onto the plant site, we have linear sequences set up. We have specific tasks to fulfill with specific products at specific volumes and specific intervals. That's science. And we need to apply a scientific model as best as we can. A bit challenging right now to re-engineer anything, in as much as we're just fighting for available time to cover the minimum bases. But we do need to apply an objective approach to how we design our machine lubrication routine care activities. I started doing this work 33 years ago, and the old gray-headed man who was my mentor taught me to do this largely from a lubricant-focused perspective. Now, we're going to use this product over here in this application, and we're going to feed it every 2 weeks, and then over there we'll use this other product and feed it every 1 month. And my question to him was, well, why? Why is it different? And his response was, shut up and write. Just listen to what I'm saying and do what I tell you. Shut up and write. And I practiced a lubricant-based program design mentality for the first 10 years of my career. And it wasn't until about 20 years ago I realized there's a flaw in that approach, and we need to take a much more objective approach. There's lots of methodologies that are available to us in the form of ISO/DEN/ASTM standards, standardized engineering principles and practices that can be applied, should be applied to our machines based upon their relative criticality and operating duty cycle. And when we do that, we have the means to right-size our lubrication program to provide an optimized or best fit, if you will, amount of daily care and feeding to the machines according to their need to contribute to the enterprise's long-term well-being. So whether it's now or later, some of the things that Rich has talked about are going to come into play. Hard, cold, simple fact of the matter is, much like the notion of the nuclear promise, we all are going to have to figure out how are we going to go about getting the work done in the future with fewer hands available to pull the load, to support the load. It's a demographic challenge. It's not just a COVID-19 challenge. Of course, that's our immediate concern. But for the long haul, we are going to have to use automation. We are going to have to optimize our care and feeding intervals. And it's time now to dig into that. It's kind of a matter of re-engineering lubrication program. And I think we're all going to find a lot of time-saving opportunities in the midst of that as we move down that road.
Mike, that's an excellent point. Actually, I think that so many of us now, like you so astutely pointed out, is that we are having to adjust according to the present situation. And really, it's now become a manifestation of something we've always had to do, but never really recognized until now. You know, I think I mentioned this at the beginning of our webinars back several weeks ago. I've been commissioned to write another book it's called Pivot: The Unforeseen Consequences of the COVID-19 Pandemic. And really what it is, it's examination of the social implications, technology implications, and even the environmental and business implications of this now financially constrictive scenario we've been battled in now. And it's kind of an interesting examination in the fact that there's certain companies and certain individuals that can pivot. And you and I and Mike and Matt and Rich and Nate and so forth have used that word now so much more than I think we ever have. But the ability to adjust according to the lay of the land, the way the winds are blowing, and the shape of the sea. And so many folks that are failing and businesses that are failing didn't have that opportunity to adjust and to pivot. But I'm really interested to find out, like you said before, is that when we do take a look at sending out for the whole kind of labor examination in these various tasks, what has to be adjusted, and it really has to be adjusted quite often in order to constantly tweak to get the proper response out of our signal, if you will, and to continue to calibrate and standardize and recalibrate. And really it's all about the pivot. I'd love, for those of you out there that are still on board and listening, please send me an email. Let me know what you guys are doing personally, be it technically, socially, environmentally, and business-wise, as to adjusting what you are doing in this whole COVID-19 pandemic, and how it's affected you, what you did to actually counter that challenge, and then if it was successful or not successful, and did you learn from the failure opportunity and readjust, or are we just going to stick our head in a bucket and get doped up, whatever the case may be. But sure would love to hear it, because Mike, you provided an excellent example of exactly the technique to do just that, which is to adjust and constantly recalibrate ourselves. Great points.
Thank you, Mike. Hey, time for your wrap up. I'm all done. Appreciate the chance to visit with everybody again.
Sounds great, Michael. Thank you so much. I appreciate it. Hey, just to recap, just to talk a little bit on certifications. And certifications, once again, they're a wonderful acknowledgement of hard work put forward. And there's lots of different reasons why people try to get their certifications professionally and whatnot. Now, it's all about having an incentive. We're incentivized to do various things in life. We have our personal incentives. We have our social incentives. We have our financial incentives. Perhaps your company will give you a bonus if you get your college degree or get a graduate degree or get a professional certification. Or you might be actually recognized by the community as being a real smarty pants, whatever. Or personally, you look at it as a challenge to better yourself. And whatever your incentive is for getting it, doesn't matter. It's all good, because whatever you're doing, if you're advancing the cause of your intellect and you're trying to delve deep into an idea, concept, anything like that, you're only going to get better from it. And I think certifications provide that sort of framework. Now, we talked about this before, is all the stuff in these certification preparation classes that we all put on, and the documentation out there and the body of knowledge. It's teaching you how to get up to the plate and hold the bat and keep an eye on the ball and swing appropriately. But if you take a look at how major league ball players approach how their hitting is, they all have different stances. They all have different ideas. They all go for different types of pitches. It's all really personalized, but they all have one thing in common. They know how to hit the ball. And they know how to hit the ball because they went through a certain amount of training. And that's what these certification preparation experiences provide. They establish a foundation. Now, how you build that house, whether you decide to go modern, whatever, or colonial, doesn't matter. Each house needs a foundation. So regardless of the design, these certification preparation experiences provide you that foundation to explore and expand on. And I was always asked the same question, is that what should I start out with? And I think Matt and Mike and Rich and so forth have always said this. We start out with, say, the MLT and the MLA, either one. I mean, you can't go wrong with either one, and then go from there. You don't just have to get one. You know what? And this is like anything else. It's a learning experience. You don't have to necessarily just be settled with the high school diploma. Go on. Go on to get your college degree or postgraduate degree, whatever it is. Don't ever stop learning, because when you stop learning, you begin dying, and nobody wants that. The whole idea of a living organism is to stay alive. So stay alive, and the only way to do that is to constantly improve and get better, adjust according to the process, adjust according to the failure opportunity presenting itself, and just get better from it. We're here to help you all out. Look forward to working with you going forward. We're rounding up on the 10:55 hour right now. If anybody got anything else to recap this out, love to hear from it. Go ahead, Matt.
Not necessarily a question, Michael. We just want to make sure that everyone knows that all the recordings from our last session and this past week, as well as this conversation today, will be posted up on a group YouTube channel. So while the 4 presenters are in fact 4 unique organizations, we've come together. This is our second week now of coming together to present the end users with some what we feel is usable data. So everybody will get a link to that YouTube channel that will have the video presentations of this past week, as well as the videos we did 3 weeks ago. So we want to invite everybody to check that out when you get the email. And as Mr. Holloway stated, if anyone on this call has any questions or needs any support, really in any realm of lubricant analysis, whether it's lab-based, sensor-based, any type of certification training, customizable training, reach out to us. All of our contact information is on the various videos on YouTube, as well as on, I believe some of the emails that went out. So I just wanted to do a quick reminder of that before we logged off there, Michael.
That sounds great. Thanks a lot. It's just some of the nuances. And I always try to pigeonhole, because my small brain can't do anything other than figure out how the various things fit into certain, gaps and holes and so forth. And I look at the MRG laboratories as the grease experts out there, the folks that are really getting a handle on. Nobody's better at understanding grease and lubricating grease than the MRG laboratories. I look at Amory, and those are really the consulting the consulting arms to really get a true understanding of the work that's needed to go in and lubricate and manage a lubrication, everything from a storeroom on through to the various tasks that are required, and really get a nuts and bolts handle on exactly the kind of costs that are associated with these things and how to go about reducing costs. I look at Delta P Reliability Services, and that's an organization that does the consulting as well, but they also go into the whole concepts of inline oil analysis and eventually probably even inline grease analysis, the things like that, to where you get a grasp on the next level technology that's emerging on the horizon. And Delta P can actually take you to that horizon. A lot of times we're stuck on the shoreline, but I think what Matt's put together is a vehicle to bring us to that end gap. And, you don't fall off the edge of the horizon when you go sailing. You explore new worlds. And I think Delta P will do that. And as far as fifth order industry, well, that's all about the training and competency development. So that's my shtick. Anyway, sounds like Rich is opening up a bag of chips, and we're falling into the next half minute. You guys have anything last words to say, Rich or Mike?
Yeah, I don't have any chips, but that's a good idea, Mike. But I just wanted to leave people with the idea here that we're gonna close this session out, and when we do, it'll put a screen up that has all of our contact information, so you can reach out to the individual that you think is in the best position to help you. And if we know that one of the four of us has an aspect that can do even more, we'll make sure to get the right person or organizations involved to help you out, whatever your challenge is related to training, setting up sensors, doing analysis, what have you, setting up your own lube routes, these kind of things. And so, yeah, that's just what we want to do. And then also, reach out to us about topics you'd like to see going forward. We kind of felt that we had some key topics that we wanted to bring forward in this time of COVID-19. You, the audience, can set that agenda going forward. Just reach out to us. Let us know what you'd like to see next.
Good summary, Rich, Mike, Matt, Rich. Thanks for your contributions here. Very much enjoyed working with you guys. I don't have anything further to add, Mike. Appreciate your time.
All right. Hey, thank you all very much. And please stay in touch with us. Stick on board. I'd like to hear from you in this quick little short questionnaire. But hey, thank you so much. Look forward to doing this again.